essentially three kind of major parts of our business. There are the retail division, which focuses on gas, electricity supply, but also energy services, so things like electric vehicle charging network. So that's probably what a lot of people think about ScottishPower, the retail facing side. But then, of course, we also have the energy network side, which is both a transmission and distribution business. So they are absolutely critical infrastructure across the UK. And we have renewables. And our renewables business is very international, as you would imagine, largely covering onshore wind, offshore wind, but now solar, moving into battery storage. And we'll touch on some of these points today as well. So I think the overall context is that we know that we have a very critical role to play as a large company in the UK, but we also have a role to play as part of the Iberdrola Group. And if you don't know the Iberdrola Group, they're a global utility headquartered in Spain. So we have operations in Spain, the US, Mexico, Brazil, Portugal, Italy, all kind of around the globe right now. So that gives us leverage and knowledge. It allows us to build and learn in maybe one country faster than another. We can interact in different markets and take a lot of learnings for the wider benefit of the group. So that's an interesting dynamic for us as well. And actually, I'm going to cover that a lot today because a lot of the knowledge and forecasting that we do internally about how the future energy and overall community of energy works in the future, a lot of that is international knowledge. So you'll hear me refer to Iberdrola a lot. So key areas that we'll cover, and as I say, I will try and rattle through quite quickly. I do apologise if I go over things at a very high level, but also I'll just try to cover to keep it quite sharp because I would much rather hear your questions towards the end. So we'll start off just a wee bit of global context and how that filters into the UK specific challenge, and then probably the majority of this is about how do we form a view across our colleagues internally what our future business strategy is based on a technology outlook for 2030. And I'll cover what the component parts of that are. And then at the end, to show you real projects, real people, things that are going on right now, which is always good to see, so it brings it to life. So a wee bit of global context only. When we talk about net zero, and we talk about green recoveries, and we talk about investment and climate change, and our fight against climate change, sometimes it's actually very easy to forget why. And you can get bogged down in thinking about, it's electric vehicles versus hydrogen. It's the way that we should have hydrogen heating in homes, or CCUS, what role does that play? And the truth is, all that's kind of technology based, obviously. It's, horses for courses. It's what's right and what's cost effective at any point in time. But this is why. So the only thing to really highlight here is the difference between 2030 and 2050. The benefits that you see there, the large kind of increase in health, the light blue, and the benefits in greenhouse gas emissions and reducing those. We shouldn't forget that that's why. Because as I say, you can get very artificially caught up in some arguments about whether one thing should be supported over another, but we shouldn't forget that all of society benefits from cleaner air, from less pollution, from reduction in kind of illnesses or respiratory illnesses, which then put stress on our health system and costs and all the things that we know about, and is a very prominent point for us all right now. But this is why. So I just think it's always good to remember that global context, that it's not about choosing one technology over another, it's trying to chase these benefits. And so one thing that I really like, and I'm going to use them a lot today, hopefully people have seen them before, but I will cover them very, very quickly, Sankey diagrams. So this kind of diagram I really like because it gives you an overall view. And this is a snapshot of, if I remember correctly, from a few years ago. So this is the world energy picture. It might have been 2015, 2016 type range. So what this diagram means, if you haven't seen this before, once your eyes have adjusted a wee bit, is the left-hand side, primary energy, tells you where the energy comes from. So what's the raw source, basically. And then you move into the final energy. So part two there in the middle is how it's used. And then third element is just saying, well, how much was lost, what's been useful. And what you get in the middle is that we've highlighted here in this diagram is electricity generation. So this global picture of how energy was used, as I say, if I remember correctly, it was a good few years ago now, maybe 3 or 5 years old ago data. But the point is still the same. We are still very heavily reliant on oil, obviously for transport and some of the other sectors there in final energy use. Coal, of course, is still widely used across the world, and a lot of that goes into electricity generation. Gas, as we know, and renewables globally isn't as big as it should be, so we know that. So obviously we also know that the opportunity now is to try and strip away that oil, strip away the coal, and reduce the reliance on gas, and really build up that contribution of renewables. But when you look at this system, you do have still, and it takes a long time obviously to transition from this, you still have a strong reliance on fossil fuels, which we need to get away from. But because of the inefficiencies throughout the whole kind of energy system in this context, you're actually introducing a lot of losses through lots of different kind of energy transitions, as many people on the call will know. But really, you're only boiling it down to only getting a third of usefulness out of it. So then, as we see, well, as we move to more and more renewables, obviously efficiency goes up as well. And we start to move away from kind of traditional and more conventional thermal generation with higher carbon emissions associated with it. So that's the global picture. And what we have the opportunity now is to move away from this. So it's a big, big challenge. In terms of CO2 emissions, this is generally where it comes from. Again, this is kind of an international picture, so I'm sticking with the global outlook right now. But you can see we do have that heavy reliance on all the fossil fuels, how it's used. And so our challenge, and it is absolutely an unprecedented challenge, is to make it clean, because we do want that cleaner air, we want to reduce gas, we want the reliability that we've always had. You know, having blackouts and intermittent generation, which is in some way causing other problems, is not going to be acceptable for future society, and absolutely it has to be affordable. So these are the three things that we're trying to tick, and it's an unprecedented challenge because obviously of the speed of change, because of the scale of the climate change fight that we have in front of us, not least because of changing society dynamics. Obviously we do want economic growth, we want universal access, we want more and more people to be able to access energy readily, reliably, affordably. And so not only given what we have as a challenge, we're actually trying to grow that as well. So in that global context, the UK challenge, very similarly, there's a few things I think worth noting. And again, so I'm sticking with the Sankey diagrams now that hopefully everybody's kind of got their head around them. This is one that I really like to talk about actually. It's quite a recent one, it's come from June, a report by Aurora. And the overall report from Aurora that I've borrowed this from was about what could the future role of hydrogen be in the UK by 2050. And this is just one scenario, so this is not a forecast by any means. It's just one of the scenarios to try and work out, again, in Sankey diagram terms, where would our energy come from? What would the intermediate steps be? In the middle, as you see, electricity, hydrogen, and where would that energy go? And so there's a lot to note within this, but there's only a few things that I'll pick out. The first thing is the growth in renewables. And it is enormous growth that is required. Again, this is 2050. This scenario is high renewables. And so that, compared to where we are today, is a big, big jump. And there's a lot of that actually we can see coming down the pipeline. We know that we're going to have massive growth in offshore wind because we're opening up new areas. We have much bigger wind turbines coming along. We have greater efficiency, so we can get more energy down the lines. We need to do more in onshore wind though. And of course the cost of solar comes down so much that actually we're starting to see greater deployments there as well. So that helps with the renewable section. But the truth is, if we want to get to a picture like this in 2050, we do need to see an enormous growth in renewables, which is only a good thing. Now, some of that comes from things like changing the demand side. And so if you reference where we kind of think electric vehicles are going, and again, you could replicate this for things like electrification of heat, as we know, and heat pumps, you start to look at a much bigger demand coming from cleaner technologies on the usage side. And so these are also quite big numbers. And we shouldn't remember that we actually do need to build these renewables to satisfy these things. Some of the things that can be a wee bit frustrating at times in the media or the marketplace is when you hear about 100% renewable supply, 100% renewable tariffs to people's homes. And sometimes that's just certificates. Sometimes it's just pieces of paper being traded in the background. What we actually need to do is to be building the assets on the back of that as well, to then power the electric cars, the heat pumps, and electrify the economy in the future. So that's just one aspect that feeds into that growth of renewables in terms of the source side for the UK. And that's obviously, as I say, directly linked to more efficient electrified uses. So transport, I've mentioned, but again, so if you stick at transport and you look at that kind of transport 118 terawatt hour number, a vast majority of that transport is now coming from electricity, which can only be a good thing. And hopefully, I mean, this would be an opportune time in a kind of a physical conference to ask for how many people have got electric cars, for example, or who's thinking about changing. But so this transition is happening. I've got an electric car. I'm also a massive kind of car and petrol head, but I've made the transition. And so I think that is where we need to go, that portion where you see electricity now starting to feed transport. And you also see a wee bit of hydrogen. So you see that blue line coming down from hydrogen, feeding down into transport, which absolutely makes a lot of sense, whether it's larger vehicles, larger range. There's absolutely every place for that as well. But then if you look up to heating, again, a massive change there, where obviously heating is probably the biggest challenge that we have, certainly in the energy context in the UK. There's a lot of electricity that can go towards that heating demand now. And as you can see, a line comes down from hydrogen as well. And hydrogen heating absolutely may well play a role in heating in the UK in 2050, certainly, because this is a long way away. We've got lots of time to make this happen. But we shouldn't forget that proportion there between hydrogen heating and electricity heating, that's not actually proportional to satisfying the demand, because we shouldn't forget that electric heating is far more efficient. And so that proportion, actually, they've made a very useful note on the diagram, which explains it far more efficiently and effectively than I am. But the point being that electricity feeding heat pumps actually does satisfy a much bigger chunk of that heating demand. So we've got a lot to do in terms of the user side, the demand side of efficiency and technology use as well. And one of the things that we've done, again with Iberdrola context, so my very, very clever colleagues at Iberdrola started to pull together, well, what does it mean quantitatively when you start to compare types of vehicles, and you follow it using this phrase well to wheel. So rather than just the kind of diagram down the bottom is quite helpful. When you see TTW, that means tank to wheel, and that's when you can start to look at, okay, for that vehicle, how many miles does it get per hydrogen refueling stop or electricity recharge, things like that. But we also wanted to look at the whole picture, so which is why we've looked at well to wheel. So we have lots of these different comparisons, and these numbers, as you would imagine, change all the time. But there's a couple of things to pick out. And what I should mention, actually, when you look there at the principal fuel column, and you go down to electricity mix, and it says ES 2016, this is based on Spanish numbers, which is obviously the best data that they had to work from. So, but again, a lot of it is very internationally relevant. So you look at efficiencies, for example, between electrolysis, creating hydrogen for then hydrogen vehicles. Again, we're still looking at battery electric vehicles as being the most efficient. And then when you look to the case down below, which is electricity mix for Spain in 2030, which predicts obviously a higher penetration of renewables, you still get the same efficiency change, but of course there are far less emissions. You would like to think associated as the grid becomes decarbonised as well. So there's a lot of kind of background data that I think we have to look into this, because we know that there are still some constraints around battery vehicles, and what kind of range do you expect, what kind of cost point do you expect. But these are the kind of things that we know are coming along. They are coming by 2030. As I say, I've already got one and we're looking to actually upgrade to our next one as well. So the transition has started. But an interesting point I really want to make about not just electric cars, it's very easy to get caught up in just thinking about suburban homes, detached houses, electric cars charging. But when you think about buses, and particularly electric buses, hydrogen buses, there's a massive energy requirement there, which we all know, and in some cases even more so for the rail network. So large portions of the rail network, of course, will become electrified, rightly so, and yet some areas may benefit from hydrogen fuel trains, either as a transitionary step or actually as a permanent solution. Now, as long as that hydrogen can be created ideally through electrolyzers fed by 100% renewables and get to that kind of green hydrogen ecosystem, then if that's the right thing to do, then absolutely it all feeds into the electrification story. And shipping obviously is a very, very tricky one, and I'll get this wrong, but I'm sure there's something like the top 15 vessels in the world produce more of the more poisonous end of gases and emissions than all the cars in the world. So those top 15 shipping vessels, if there's things that maybe hydrogen lends itself to, if there's other fuel types where we can start to reduce the pollutants coming from shipping, and of course we've got the challenge of aviation, then that all makes a massive, massive inroad to reducing those carbon emissions, reducing air pollution, and a lot of it will rely on electrification one way or another. So transport, massive element, as we know. And one of the things that we've tried to do here is really focus on electric buses, because across mainland Europe, actually the orders and plans for electrification of buses is growing very quickly. And also in the UK, we've started to see our business start to support some of these electrification of public transport as well. But there's a lot of factors in that. And for anyone who has an electric car, you will know that there are many things that affect the battery range, not least the weather. And so one of the things you'll note down the bottom here is weather is a very big factor. And I've certainly noticed it in the winter versus summer range as well. But it's everything. It's how does the driver drive the bus? How often do you stop? What roads are you going on? Are you going uphill? And so there's lots to consider within this, but overall, what we've managed to do is create some internal tools to try and help either policymakers, local authorities, any kind of operators and bus investment decisions to think about total cost of ownership. And so there's a lot within that, as you'd imagine. What about the charging infrastructure? Do you have a bus that leaves the depot in the morning and can effectively run for 12, 16 hours and actually does all its charging at night? And what is the cost and operational implications of that? Versus another model, which is more of a kind of grazing approach, where the bus has a natural point in its operation where it can charge for 30 or 60 minutes and kind of top up throughout the day. That has very different implications for the electrical infrastructure and also for the bus type as well. So we've spent a lot of time trying to do these things where we're trying to build up that total cost of ownership, because of course you have also the carbon emissions as part of that, and absolutely key to all of it. So these are the types of things that we've tried to educate ourselves in internally, and what it does is all feed back into our picture of 2030 and beyond. So to come back to, that's talking about kind of transport on the user side. And to come back to this final element that I'd like to draw out of this diagram is the relative proportion. So we've done a lot of work, as you'd imagine, across the Iberdrola group, looking at where does hydrogen best fit in and where can it help us decarbonise faster, cheaper. And so we always come back to this kind of element of kind of 15 to 20% roughly of the energy system as being that's a really good place for hydrogen to be, either because it's going to take an enormous amount of technology advances in electrification to try and electrify and decarbonise those particular sectors in the energy context, or it's more cost effective. So things like industry, and particularly things with high temperature requirements, absolutely hydrogen lends itself very well to. Electrification might struggle to reach either high temperatures or certainly cost effectively reach high temperatures. And of course, hydrogen may well have a very good role to play in heating, as we know, and transport. But I think one of the main things to notice here is that we really, in our opinion, need to get behind green hydrogen. And green hydrogen being more modular, because electrolyzers you can pretty much put, pretty much anywhere in the network, distribute it around where you need it to be. It feeds off renewable electricity and renewable generation, which is something that we should push ahead with absolutely as well. So you're almost kind of building that ecosystem and reinforcing that ecosystem by saying, if you need hydrogen, absolutely, let's use the electricity network, let's use renewable capacity which is being built to make cost-effective green hydrogen. It's not to say that there won't be a role for all the different other types, blue hydrogen, and I know was it the German energy minister maybe started to talk about turquoise and aqua, and there's probably other flavours out there which are, that would baffle me. But the point being, if we need to do all this decarbonisation, and we shouldn't forget, as fast as possible, we have the electricity technology right here, right now, largely off the shelf. That can also feed electrolyzers stationed where we need it to be, and therefore we can see this kind of picture materialise very feasibly by 2050. So there's a couple of things to learn though in terms of that networks and electrification piece. So when you think back to the, I'm not sure it's the right word, let's say the explosion of solar PV across the UK, that was largely driven by just surprising reductions in the cost, and also positive government policy. And so all the predictions for government were outstripped, met very, very quickly. But what that did mean was that there was a lot of installations going on that the distributed network operator either didn't know about or wasn't able to react to as fast if they had a stronger role in the planning of that. And so there's other things that we talk about a lot about behaviour, and we talk a lot about energy demand behaviour and consumer behaviour in the future. We talk about vehicle to grid and home smart tariffs. And there is a question there which still has to, I would say, be bottomed out through things like pilots, but very large scale pilots. So as I say, I've got an electric car. If I have it plugged in at the side of my house, how more expensive would it have to be for me to not want it charged at certain times of the day versus allowed to charge, let's say, for example, for free at night? And how many vehicles out there allow that? Can you do it on your app? So if you multiply that against hopefully what is a large-scale deployment of heat pumps in the future and more kind of Internet of Things and smart appliances in the home, we need to think about those pricing signals. If we want consumers to behave in a certain way because it's for the overall benefit of the system and more cost-effective to do so, how big do those differentials have to be? It's a really interesting thing to see how people react. And then things like smart charging, which again could be replicated against things like heat pumps and controllability of heat pumps in the future. We've done a lot of work in our distribution side of the business where you look at things like, for certain regions, if maybe you are, say, the first out of 10 homes in your street to ask for your electric vehicle charger to be connected, a lot of that can actually be very easily managed and connected. But perhaps in certain regions, once you get to maybe 1 in 4 homes start to convert to electric vehicles, in some areas that will start to cause some problems, and you don't want to be in any way slowing down the transition to clean vehicles if you can avoid. And so smart charging is absolutely essential, not least because it could actually almost half the cost of some of the changes and network investments that have to be made. But again, there's a lot of consumer behaviour within that as well. So I think there's a lot of lessons in that, back in the context of how does the UK take on this challenge. So I think what I'll do very, very quickly is go through a technology outlook, which is something that we build up within Iberdrola to try and inform ourselves for 2030. That informs our business decisions, as you'd imagine. And so this is very technology based, and I'll go through it very, very quickly because I'm sure a lot of people on the call know a lot of this. So we've talked about this transformation that's required. We have to make moves on both the supply and the demand, and all the enablers in the middle are really, really interesting parts about how intelligent our grid can become, how grid aware controls and technologies are, and all the cross-cutting things that we do in terms of digitalisation, as you'd imagine. So we very much see it as a jigsaw. Yes, there are certain technologies that we are more comfortable with and will invest in, and they are part of our, we're core to our business, but we're very aware that there's lots of other pieces of the jigsaw that even if we don't necessarily want to own or build or operate those assets, we know they're part of the jigsaw. So that's the whole point of this kind of technology outlook, and this is how we build it up. So we have a lot of great relationships across the industry space, across private, across academia. We have obviously a lot of internal knowledge, and we have a very strong supply chain. So we've really pulled on all these resources to try and build what we think is a picture for 2030. Now, if I go through some technologies very, very quickly, not in depth at all. So we'll start with solar. And we know that solar, for example, has a long way to go in terms of materials. There's a lot of space for innovation in there, different chemistries, and again, stuff that I have absolutely no idea about, but the kind of stuff that we've tried to capture here to say, okay, well, if we have innovations and advances in this element, does that help CapEx, OpEx? Does it help the overall kind of capacity factor, things like that? So this is the kind of stuff we do in terms of mapping where the innovations are. That then helps us bring it into a financial context. So for example, we'll look at the CapEx evolution. If we do, and I'll go through this example very, very quickly, if we have these innovations that we expect in the module, we expect to see that level of reduction in terms of the module, and then very obviously you start to build up this picture of where you get to 2030, but we also look at performance improvements as well, and therefore capacity factor in different regions. And what happens is we start to build up this picture about modules obviously being the thing to support right now, because it'll give us a very fast cost reduction, but we also appreciate there's a lot in the balance of system and how you operate and how you integrate your solar into any other kind of, maybe it's co-located with a wind farm or battery storage, for example. But then what we do, that I guess the way to if I back up a wee second, that's innovation driven kind of cost projections and an outlook from the innovations up. But what we do obviously is sense check that by thinking about economies of scale, about learning rates, so that if the two were mismatched, you would need to find out why. So we then compare all of our innovation outlooks with the forecasts that you might expect from a certain type of technology or sector, and they agree, and we always find the right place in the middle. So onshore wind, again, very quickly, I'm sure there's lots of people in the call that know a lot about this, and a lot of it is stuff that you would expect to see there. Of course, we'll have larger turbines, but there's quite a lot in the background that you'd imagine about things like predictive maintenance, things like that will help as well. So we do the same thing for onshore wind again, and yes, capacity factor will be a massive thing, but also where we go with our wind farms. Can we access better sites that maybe in the past technology might have held us back? Maybe we couldn't access those sites. Again, the same thing, we'll sense check it against the economies of scale and learning rates. And so actually predictions for 2030 are very good, well, across the renewable space, but certainly still in wind turbines, it's by no means reached a bottom point at all. There's a long way to go there as well. Offshore wind, a massive area. What a deep field to explore in terms of innovation, as you know. So we do the same thing, but again, this is the very exciting area of kind of offshore operations, vessel use. When you think about some of the vessels, for example, I mean, it wouldn't be unusual to have a vessel that costs £250,000 a day. So any kind of operational efficiencies that we can make, if you can change the type of vessel. Of course, we're now thinking about floating wind. So there's a massive area of growth of offshore wind and innovation space to explore into. Again, we do the same thing, And needless to say, as we start to get towards 15, 20 megawatt size turbines and beyond, and of course the floating space as well, that drives down the cost a lot. And therefore, again, we can start to forecast some fairly aggressive cost reductions by 2030, and that all feeds back into our technology outlook. One thing that's getting quite interesting, and we've worked on this for a few years, and this is oversimplistic for the sake of this talk. Of course, actually bringing technologies together is actually more like a minute by minute, if not second by second challenge. But we do know that there is complementarity, if that's a word. If not, I'm sticking with it. Let's just say that solar and wind can be complementary in terms of their generation cycles. And of course, when you bring that together on average, it makes a lot of sense. But you can also bring it together in very real terms. And so we're exploring far more co-location of more than one technology for that purpose. And a key thing to that, obviously, is storage. So whether it's on that kind of site basis storage, where maybe you have a wind farm, solar, and you'd like battery storage to help level out those peaks and troughs, or it's large-scale system-wide and system-scale storage like compressed air, like hydro and pumped hydro storage. These are absolute core components to energy in our system, and so we are continuing to move ahead with hydro and pumped storage, certainly in other Iberdrola areas, and we are currently building a 50 megawatt battery in the UK up at our Whiteley wind farm, because again, it's horses for courses. It's what do you need it to do, and therefore we will try and inform ourselves about where these technologies are going, again in the context of informing our 2030 outlook. And so we've looked at lithium-ion batteries, as you'd imagine, alongside other types of energy storage. There's a lot to be done there, of course there is. We need to think about the actual core materials themselves and how sustainable that is. Do we start to move to other types of flow batteries? I know many of my colleagues like compressed air, for example, as a technology. So we need to look at these things, but certainly by 2030, we can start to build up this picture of innovation activities, what's going to come down in cost, how that then affects the cost by 2030, where the biggest chunks of innovations and where to focus on. There's also the battery pack, but then there's the wider system and how you operate that system. And so actually, I think we can be quite aggressive still in terms of potential cost reduction in battery storage as well. And again, the learning rates have been quite aggressive historically for lithium-ion batteries, and we're likely to see that continue for a good while yet. Because it's lithium-ion batteries, that also feeds us into electric vehicles, and obviously the two largely go hand in hand right now in terms of forecast of reduction of cost, about battery range per vehicle. And so absolutely key aspect in our 2030 outlook is how do electric vehicles play a role within that. So we do need to think about when do you reach price parity, and very quickly. I do very much understand cost and range anxiety, right up to the point that I actually bought an electric car, and then I had no range anxiety. I had range awareness, but I've also got a petrol car as well, family car that sits in the garage a lot. I've got range awareness in that because it's fairly petrol thirsty. So I don't really. I think range anxiety is still a phrase that we are going to hear less and less of, because it's not. It's range awareness, and actually with electric cars now with 200 miles plus range, that's less of an issue. And cost, for example, three years ago, I bought a second-hand, one of the smaller kind of first generation Renault Zoe cars for, it was about £6,000, something like that, because I thought we're doing it, we're going to get one, we're going to see what it's like. And just as an experiment, I put it into We Buy Any Car last week, and it's coming back valued at £6,000. So one, it's for sale if anybody wants to buy it. But the point is, cost absolutely is an issue if you're going for brand new cars, things like that. But these things are coming down all the time. So electric vehicles is a key part of our forecasts, and I'm not going to dwell on this, but again, heat and what the overall system of heat looks like. So This comes from a kind of a European breakdown of heat, and again you can see the reliance on fossil fuels, which we know electricity, district heating, heat pumps there at 21%. We know that should be far greater, and that should become hopefully the dominant technology that provides our heating as well. So that's a very quick whistle-stop tour, but hopefully you can see that all these things and all the good work in the background comes round to our overall consolidated technology outlook that basically tells us that we can make it clean, we can make it reliable, we can make it affordable, given all the things that we've just been through. And that leads us to this picture of the electrification of the economy. So these are our conclusions. That then informs us as to where we will focus either our innovation activities, our project development activities, where we'd like to invest money for the next coming decades. And so electrifying as much as possible and as fast as possible is definitely what we believe to be right, given all the evidence that we've looked at. So I'm going to finish with just actually a series of nice pictures as much as anything, but the point being that I'm very aware I can flick through these things ad nauseum, and actually what happens and what matters is real projects at the end of it. So here's some real projects that we're working on. This is in Spain, at Puerto Llano, where we are helping an industrial customer transition to using green hydrogen. So this is it in real life. We have a solar PV plant with co-located battery. It feeds into the grid, but also then feeds into a 20 megawatt electrolyser. That creates the green hydrogen for the industrial plant, which is used for actually fertiliser, which is a big energy demand, not just in Spain, but across the world. And so this is a perfect example of how we can start to use electrification into green hydrogen to help decarbonise an industrial part, an industrial sector that otherwise would struggle if we try to do electrification alone. So that's happening. Another key thing that you'll see in the press is the growth, hopefully, in electric vehicle charging networks. So the difference in the approach here is that this is being led by our SP Energy Networks division, and that's the transmission and distribution network operator part of our business. So it's different because we also have a retail side, and they're also looking at commercial and market opportunities. But this is a different prospect because it's a partnership with another DNO and also the government to basically try to lay out almost like a grassroots network of electric vehicle charging, which provides universal access to everyone. So we know that there will be commercially attractive sites out there. So let's say, I don't know, a major inroad or major roundabout somewhere in an urban environment where you can think about fast throughput of vehicles. They want to come for 15 minutes, fast charge, they're willing to pay £5 for it. A very commercial driven prospect. And what we can't do is let that be the only way that electric vehicle charging infrastructure comes to the fore. We do need to make sure that it's fair and equitable, not just in terms of cost, but also geographically as well. So I think this is one of the most important things that makes sure that electrification is geographically fair and spread across the UK. So I would keep your eyes out for that. And something I mentioned already, we were looking to bring more technologies together to make the best out of grid connections, physical assets, natural assets. And so we're currently in construction, as you can see there, of a 50 megawatt hour battery next to our Whiteley wind farm, again, because it's a very key point on the electrical network. So these are the kind of things that can then support the National Grid ancillary services contracts area, and it's something that can improve reliability and improve the penetration of renewables in the system as well. So these are all very real projects, and one that I'll finish on, because it's one that I'm working on live right now, is to try and promote a kind of net zero living, net zero society, which brings together commercial premises, domestic premises, transport, you name it. So it's a site in the south west of Scotland in Kilmarnock, where just now it's just derelict land. But the idea there is to create new commercial premises, both office buildings and working areas that could be maybe small manufacturing or 5 people business type areas, but also up to 210 new homes. And so when you get that kind of mixture of 200 odd homes, 20, 30 commercial premises, large office buildings, maybe in sports centres, you start to get basically a snapshot of what a small society could be. And that site will have no gas at all. That will be a 100% electric site. And that will therefore encourage electric cars there. And there'll be charging hubs to be served by hopefully electric buses, solar generation on site, battery storage on site, low carbon heating. So we'll be looking at things like ground source heat pumps there. Now the point of that is that it should all be affordable. It's all based on electricity, and it shows that it can be done. So that's a very exciting project. Again, you may well see that in the news and something to keep an eye on as well. So I'm sure for anyone who's wanting to just catch the highlights and has slept for the last few minutes, tens of minutes, here's where I'll finish. So there's nothing clever in here, but hopefully I've highlighted the points that, of course, we need to reduce our reliance on natural gas, not just because of the carbon emissions, but it changes the consumer behaviour as well, and the consumer behaviour feeds back into use of natural gas. And so we also need to increase our renewables generation to then build up that greater generation capacity for all the things that we've talked about. And we've got a lot to do on the way that we use that electricity, both in transport and heating. But the main things, hopefully you can see that electrification is a critical enabler. And what I mean by that is, even if you get caught in one of these, at times, I think, unhelpful conversations about hydrogen versus electrification, which is really unhelpful and actually in a lot of ways doesn't make sense. Even if you are a massive fan of all the things that hydrogen can and should do in the future, hopefully you can see that actually electrification helps that, because electrification can happen now. It can help the transition to a lot of demand side technologies. It builds up the electricity network, which then perhaps allows things like electrolyzers to be distributed around the system, and therefore you can get hydrogen, green hydrogen, where you need it, when you need it. And key to all of that, again, hopefully you've kind of taken away the point that if we don't invest in the transmission and distribution system, then all of this is a bit of a waste of time talking about these things, because we'll start to reach limits in what the network can allow us to do. So we really need to spend that money as a society, as an energy system now, because it unlocks all the other doors. So I hope that's been useful. I know it's been a bit of a rattle through, but as I say, I know there's a lot of knowledge around the table and in the virtual room today, so I didn't want to labour any points in too detailed a fashion, but hopefully you get my main principles.
Will you put the cost onto the customer?
Well, no, thank you, George. I mean, ultimately, we're all paying for everything. So, I mean, I do kind of take your point to some extent, but when you think the electrical infrastructure is there to serve us and what we are doing with it, the same way as the health system is there to serve us. And so if you, in a very roundabout way, and actually I'm sure there's somebody clever that can do this actually, when you start to look at the benefits of, let's say, electrification of transport, and there's some horror stories out there about levels of pollution, for example, in Glasgow city centre, and I know I've seen headlines about the dirtiest street in the UK or the dirtiest street in Scotland, whatever it is, because of the amount of buses that go up there. And there's been direct links drawn, obviously, between public transport, could be fuel poverty, it could be less affluent areas using that public transport, and then you would argue that actually they're being served by diesel buses. So then what is the implications for the health system on that, and particularly respiratory illnesses? So if someone can do a really good rounded calculation, it's saying, well, actually, if we invest in this, we're going to reduce the cost in this, and it's too simplistic, of course, to say if we buy an electric bus, we've saved 10 hospital beds or something like that. I'm not suggesting it's as simple as that. But when you think of the overall spread cost of electrifying things versus not electrifying things. And I don't see what the alternative is. We're showing that the costs are coming down. We're showing we can get greater efficiencies. And when I talk about heat pump efficiency, I talk about trying to get COPs of 3, 4 efficiency, so it's more efficient to use a heat pump for whether it's space heating, whatever. So we're showing that you can get more out of the same amount of money. We're trying to show that if you invest in the right pieces of infrastructure and assets now, we can actually get bigger benefits on the other side than not, if that makes sense. Now, I know there'll be parts of our business that actually have published very good reports on this, and off the top of my head, I can remember some numbers about some of the investment scenarios that have been proposed add something like 10 pence per year on everyone's electricity bill. And I mean, if that's not investment for the future, I don't really see the point in investing in anything. I've just been hit with escalation by the children during lockdown, asking for if they did more tasks around the house, they now need to get paid £1 on a Friday. And when I was young, it certainly wasn't £1. It might have been £1 a year. So I just think when we're in order of magnitude, we're talking about in the region of 10 pence, for example, on an annual fuel bill per household to invest in the network. I think these are the kind of things that are achievable. And if it's not achievable, then we're simply never going to fight climate change.
Brilliant. Thanks, Barry. Peter Winton, you've got your hand up.
Thank you, Seamus, and good evening, Barry, and thank you for the presentation. I just wondered, there's no mention in there of low-headed river hydroturbines at all, and yet we have quite a few rivers, and Finland runs almost its entire country off of that sort of thing. Certainly that's how they produce their paper so economically. Is that because it doesn't work, or is there another reason why it's not included?
No, I mean, I simply just take for the presentation alone, I took a snapshot basically of things that were to highlight in the outlook. So for sure, you know, any technology, any low carbon technology has a role to play, absolutely. And I know actually teams across, particularly Scotland, who are looking at new sites all the time. And if that can be a component part to, again, a more distributed energy system, which again feeds into electrification, it makes a lot of sense.
Thank you.
Brilliant. George and Peter, can you put your hands back down again so we don't obscure other people? I have a question, Barry. Well, first of all, I gather that ScottishPower is committed to 100% renewables. Is that right? That's part of the mission, right? So that's a very, very attractive and bold ambition. Do you have? You showed some slides about what energy storage technologies that you plan to build, and you said that you favoured pumped hydro for the long duration stuff. Are you going to build one?
Well, we've our Carruthers hydro pump storage station was a key part of our portfolio for a long time, well, decades obviously, and now we've moved to 100% renewable generation. We still build pumped hydro storage in other countries. I think pumped hydro definitely always still has to be looked at, certainly for the UK system. One, because it's a natural asset, it's a natural resource that lends itself well, but we are looking at other things as well. So as I say, I know there's people in our business that are looking at things like the possibility of compressed air storage on a very large scale. Other things that I haven't really looked in a great deal, cryo batteries, flow batteries. I think it's one of those things that's horses for courses. As I say, if you're trying to solve obviously a transmission level problem, you need transmission level storage. If you're looking at a distribution level, community energy almost level or site level, obviously smaller duration, smaller capacity and shorter duration lends itself to that as well.
Right. I've got one more, if I'll be permitted. You did have a slide about PV panels and how that might, how the modules might reduce further in cost. But you didn't mention PVT, the combined photovoltaic and thermal, which for a Scottish person, the thermal aspect is a really big issue, less so than us relative Southerners.
Yeah, that's it. And that's, I mean, these are the kind of things, obviously, we need to update our stuff all the time. And I mean, I'm sure you've all heard of people like Sunamp, other thermal storage and battery companies are available, I'm sure, but I've got a lot of time for that. as you say, it's very much as technologies, as innovations happen, whether it's in the materials itself or maybe the integration, as much as anything is the challenge. And perhaps our future reliance on inverters is something to think about there as well. So I think there's a lot of value in that. This is exactly why we're looking at projects like the Halo project that I mentioned at the very end. The way that I would like to see those types of projects emerge is almost like a living lab, a test. So not to show that we're going to come up with a plan on day one and that's how it should be, but the kind of thing where, and I'm not in full control of the Halo site, so I can't make the decision, but it would be great to see things like, let's say 50 homes done this way, 50 homes done this way, and look at those kind of benefits, either cost or performance and these things. And more than anything, just show people that it works. I think there's still quite a kind of apprehension, certainly in terms of low carbon heating technologies, and therefore how that might feed into things like a solar installation as well, as you say. So if we can push that solar thermal piece, and in that some way drags people along the low carbon heating kind of narrative as well, these are all good things.